Okay, so now we are live. So thank you everyone for attending the Introduction to Data Science workshop as part of Hacktable 2020. And today we have with us Harkirat Singh. So I'll let you take it away.
Thank you, Emma, for giving me this platform to give a training session to all those students who are very curious to learn about the data science. So it's my pleasure. So let me give a little bit of introduction about myself. So I'm an IT professional, and I'm having about 13 years of experience in the IT industry. I did my graduation from Indiana University. Their campus is in Bloomington. So I did my master's in data science. And currently, I'm working on projects supporting artificial intelligence and data science projects. So I prepared this kind of training material. It's a very kind of introductory material. So it will help you, understand, the data science and the machine learning, from the beginning. So if you have any questions, you can ask me, and I will be happy to answer your questions. So in the data science or the machine learning, the projects. So we the main language which we use is the Python language. There is another language also used, which is called R, and that's also used in a lot of industries. But Python is used mostly as I mean, if you compare Python versus R, then most of the companies or most of the industries they will prefer Python because it's an open source language, and Python is very easy to learn and very flexible as well, because you can import some other Python modules or Python functions, and using those functions, you can you can do any kind of operations that you want. So we will go over those Python functions, Python libraries that we will be importing. So at the end of this session, like, I will be doing a case study. So that case study will be based on predicting the house prices, and we will be using very simple and basic machine learning model. It's called the linear regression model. And because all of the programming and the coding to create that linear regression model is in Python language. So let's go over the Python language basics. Let's refresh our basics, and then we will jump on to the case study.
Before we do that, we have a question from a
Hmm.
viewer. So they're wondering, why can we not use other languages for data science?
Well, it's just that most of the people prefer Python language, and Python has more libraries, more functions, and more functionality compared to other language such as R. It's not that people don't prefer R. Some companies use R, uh, but Python is the number one choice. It's just because it has more functionality. It has more libraries that you can use, for writing, machine learning models, or customizing your machine learning model. So it has more flexibility compared to other languages. So
Okay,
that's this. Yeah. This is the reason we use Python language.
okay, thank you.
Okay. So when we write any program in Python language, so the first thing we do is we write some variables, or we define the data. So we have to assign. So we define the data basically as per their the data types. So the good thing about Python languages is that you don't have to explicitly declare their data type. In some languages, you have to define the data type. For example, if it's a number, then you have to define if it's a number. If any variable of any field is a string, then you have to define explicitly that it's a string. And so, like it's a boolean, or it's a or it's a dictionary or tuple. But in Python language, you don't have to define. Basically, you don't have to declare. The Python will itself take care of it. So let me show you how it works. So let me go to the exercise. So let me create a new one. So the screen or the interface you are seeing, it's of the Jupyter notebook. Okay. So I just want to know how many people know about Jupyter notebook. It's okay if you don't know, that's perfectly fine. But I'm just curious to know.
There aren't any responses in the comments, but I'm assuming that like most people have like at least some idea about it.
Okay. So basically, Jupyter is like an complete package, or it's like an interface, the web interface. So where you can run your Python code, and it's a very user friendly, very developer friendly. And the best thing about Jupyter Notebook is that when you run your Python code, you can execute that code, line by line or sequence by sequence, and you can test it, and you can test the output. So that's the best thing about Jupyter. So let me open the Python 3 notebook, and let me show you how it works. So this is what you are seeing is basically the cell. This block is basically is called a cell. So if I type anything, so let's say I type the variable name x, and I assign the value 5, okay? And then I print its value. If you see, you can see the output right away. So this is why people, the programmers, they use Jupyter Notebook a lot. And if you are going to start your journey in the data science, or if you want to start writing machine learning models in Python language, you will definitely be using this Jupyter Notebook. Okay. If anyone wants to know how to install this Jupyter Notebook, they can let me know, and I can give you instructions how to install the Jupyter Notebook. So let me go back to my training material. So we were talking about the Python data types. Okay. So what I was talking that the Python variable, they do not need explicit declaration that this is a number, or this is string, this is a boolean. Okay. So for example, I just defined this variable x and assigned it a value 5. Okay. So I don't need to tell Python that it's an integer or it's a string. Python will itself take care of it. So if I type the function type, basically this function checks the type of the variable. So if I give this variable in this parenthesis, close parenthesis, and if I run this cell, and it shows integer. So I didn't have to explicitly define the data type of this variable. Python took care of it. I didn't have to define. Similarly, if I create any new variable and I assign it some value like hello, okay, and then I print its value, and then I also print its type. Okay. If you see, it printed the value of this variable, and it also printed the type. So, so it is saying that it's a string data type. So str is a kind of a short abbreviation for the string data type. So I didn't have to explicitly tell Python that it's a string or it's an integer. Python can take care of it. Python knows that if Python checks the value, and if it's a string, it will show it's a string. If it's an integer, it will show integer. You don't have to tell Python. Okay. So there are some other data types as well, like list, tuple, dictionary, set. So let's go over the other famous data types such as list. Uh, so let's run some operations on the string. Okay. So on the string, you can run some operations. So for example, this is the string, hello. So if I there's a method called upper, okay, and if I execute this method, it will return the string in all uppercase. Okay, so here you go. Is giving the output in all uppercase. Okay, but let's say if I want to see the value in all lowercase, so there's a method for that. I dot lower, and if I execute, and here you go, you see the output in all lowercase. So like that, you can perform these operations on the string. Okay. So similarly, there are some other operations that you can perform. So for example, if I want to replace something, if I want to say y dot space, okay, let's say I want to replace hello with word hi. Okay, so let me execute it and see, here you go. So it returned the new value high because I replaced it. I replaced its original value hello with hi. So this is how you can perform operations on string. Okay. And there are some other operations you can perform like split. So let me define a new variable. Hello, Hacktable. Okay. And then on this variable, I want to split this sentence into into two strings. Okay, I want hello as a separate string and Hacktable as a separate string. So right now it's a one string, it's a singular string telling hello Hacktable. Okay, so let's see how we split. So let's say you want to split with the based on the space. So there's a space. Okay, if I split and I don't give anything. Okay, and if I run this, so now it has returned two strings. So if you see, here's a comma, and in the single quotes there's a one word, one string, and the second word is in this, separately in this in those single quotes. So now I divided one string into two strings by splitting it. So I split it based on the space. So there was a space between hello and Hacktable. So that's why I didn't give anything in the split function, or I didn't give any value in these parentheses. But I can split based on the other character as well. Let's say I want to split based on the value h, So let's see how it works. Uh-huh. If you see, so h has been removed. So the hello word is the only returning hello, and Hacktable is returning only Hacktable. So this is how you can perform, the operations using split. Now here, if you see, you are seeing this kind of a space here. It is because there was nothing before h when we split it using h. So that's why it is showing some space. There's no character. So this is how you can perform string operations. You can manipulate. You can transform the string. You can manipulate the string. Okay. And also, let's say I want to find a character in the string which is at some position. Okay, so let me it's still hackable. Okay, the reason it is still hackable even after performing so many operations, because I did not assign it to a new field or a new variable. Okay, so it so it was not, manipulating the value the permanently. If I would have written the value z is equal to z dot split, then the z's value would have been changed. Okay, but I am not assigning any value to z. Because I am not assigning any value to z, and that's the reason the z the value of z is still as such, hello hack table. So coming back to my the previous statement, that what if I want to search some character on some certain position? Let's say I want to find the character on the fourth position, you know. So first, let me tell you how the index works. So any index in a string, it starts with value 0. Okay. So the h position is 0, and then the position of e will be 1, and then the L word will be 2. The next L word will be on position 3, and the O word will be on position 4, and then there is a space, so it is taking the position 5, and so on. Okay, so let's see, if try to find the character based on the fourth position. Let's see what it returns. Aha, it gives a value O because it's at the fourth position. If you count if you count from 0, 0, 1, 2, 3, 4. So the fourth position, you get that value. And what happens if I give value 5? So let's say I replace it with 4 with 5. It gives nothing but the space, because there's a space after O. And if I give the value as 6, it gives the value h, because this h is on the position 6. So this is how you can perform operations on the string data type. Okay, so this was, all about the strings. So there are some other operations as well, which you can perform, like concatenation. So for example, um, let's say I define the variable I. Okay, okay. So what happens if I concatenate z with I? So what if I do z I? Sorry, I have to with a small lowercase. So variables are case sensitive. So because we were storing the values in the lowercase z, when I gave the uppercase z, it gave me the error. So I will be using the lowercase z. Okay. Aha. So here, if you see, it concatenated. Hello, hack table. This is Harkirat. But there's a small problem that I want to see some space or some period. Okay, between hack table and the this word. So let's see how we do it. So z plus, uh, let me, okay, and then let me hit enter. Aha. So I see the period because I concatenated hello hack table with the period, and then I concatenated that period with another string which says this is Harkirat. So the resulting so the final result is the concatenation of all these strings. Okay, I can even add a space here. Okay, like this space. Now it looks even better. This is how you can concatenate, multiple strings. Okay. So slicing we have done, splitting we have done. Um, so strip as well we can do. So strip is basically just strips out that character. So for example, um, so there's a difference between the split and the strip function. So let me show you what the difference is. Okay, so the split is basically wherever the H word is there, it splits the string into multiple strings. So first it split the hello string into two strings, and then the hack table as well, it split it further. But in strip function, it is still a one single string. It's just one single string, but it strips, it removes the first character, which we have given here. Okay, so there is little difference between between split and strip function. So you can do more search in Google, and you can do even more exercises if you want to find, what are the detailed differences between the split and the strip, because many beginners in the data science, they sometimes they get confused. What is split? What is strip? Split is basically splitting one string into multiple strings. However, strip, it doesn't split uh, one string into multiple strings. So string remains as such, only the character is removed, the character which we are stripping out. So this is the difference between split and strip. Okay. So we are done with the strings. Let's move on to the next data type, list. Okay. Any questions so far on the strings? Okay. So I think no questions. So let's go to this list. So here so till now we were assigning just one single value to the variables. For example, we were assigning either value 5 or numerical value, or we were assigning one string to a variable. But what if we want to assign a sequence of values? So let's say I want to, let's create a list of fruits. So you can give whatever the name you like, because I'm going to create the list of fruits. So I gave the name so that it's easy to remember, so that when you look back what variable means, so then you can so here for example, if you look at Z, no, if some other person looks at this code, no one will know what the values, what the variable or what the field Z stands for, or what the variable I stands for. But if you gave us some meaningful name to a variable like list of fruits, so people can get an idea, okay, what variable means. So let's create a list. So to create a list, we first uh, type the parentheses, these square brackets, and it can have the sequence. So it can have more than one value. So let's say the first value is apple, because I'm creating list of fruits. And the another item is banana. The next is orange. Okay. So so now I executed this cell. So let me print out this variable and see what the output is? Aha. So it gives the output as a list. So if I type, so if I want to check the type of this variables, it is telling me it is a list. So this is the good thing about Python, that I don't have to tell Python that it's a list or it's a integer or it's a string. Python, knows on its own that what kind of data type it is. Okay. So this is how you can store sequence of items or sequence of values in a variable using the list data type. Okay. So let's perform some operations on the list. Okay. So what if I want to add two more um, two more fruits, in this variable? Okay. So what I can do is so for that I have the append function or append method. Okay. And in this method, I can give the values which I want to store. So for example, let's say I want to store avocado. I want to append it avocado. Okay, let me hit enter. Now check. Well, now let me check its value. Now if you see, the value has been appended. Okay, so because I appended the avocado, you can see the append avocado with the original list: apple, banana, and orange. Okay. However, there's a one catch. So let's say I append a list into list. Let's see what happens. So right now I just appended a single value. What if I append another list into a list? So let's say strawberry and grapes. Okay. And now let me execute it again. Aha. So you can see these values appended, but there's a catch because I appended as a list. If you see, there are square brackets. So what it did, it appended a list inside a list. Okay. But what if you don't want the list inside the list? You just want the values. Okay. You only want to see strawberry and grapes. You don't want to see these square brackets inside a list. So for that, we have another function which is called extend. Let's do that. Okay. So now here, oh, sorry, I forgot to give the list. Okay. So I'm executing the same statement with the cell number 25. I'm I'm again executing it. Let's see what it does. So it has been appended, and now let me verify its content. Aha. So now if you see, because I used a different function, extend, instead of append, so this did not include the list of strawberry and grapes. Okay. So it just included the original values. It did not include the square brackets. So it depends what kind of function you want, how you want to store it. So if you want the square brackets, you can use the append function. If you don't want the square brackets, you can use the extend function, right? So we have seen how we are appending or inserting the values in a list. How about removing the values? Okay, let's say I want to remove it. Let's say I want to remove this. Okay. Um, let's do this. remove. Okay, and I want to remove um, this value because I don't want to see the square brackets, and I already have strawberry and grapes without square brackets, so I don't want this. So I just want to remove it. Okay, so here on this. Aha. So this list has been removed. If you see the square brackets and the contents inside the square brackets, they have been removed. You just have to use the remove function. Okay. But let's say, what if I don't want to give the whole name? It's a big list. I want to make my life easier. Okay, I just want to give the position that there is some item at the position 0, 1, 2, 3, 4. Okay, so at the fourth position, I want to remove this. So let's see if it works. No, it doesn't work with the remove function. But I still want to make my life easier. I still want to, give a very small value in the inside the parentheses because I don't want to give this full a big name, a lengthy name. I just want to give a very short value, a very short and integer value. So how should I do it? So for that we have another function which is called the pop function. So instead of remove, I will say pop. Basically, it pops out that value. So let me give. Okay, but now we have at 0, 1, 2, 3, 4. So we have at the fourth position now we have strawberry. So let's see if does it remove strawberry or not. Let me run this. Uh-huh. So it has removed the strawberry. And to verify, let me run this list again. Let me verify the contents of the list. Uh-huh. So if you see there is no strawberry. Okay. So I also want to, highlight that there is a difference between the execution style of some functions. Okay. So for example, in so one difference between remove and pop function is that in the remove function, you have to give the value, what exact value you want to remove. Okay. But in pop function, you don't have to give the exact value. You just give the position, at what position that value is, and then Python will search for that value on that position, and then it will remove. Okay, so that's the first difference. Another difference is that when you run the remove function, it doesn't give the return, but it's the output. Okay, it's not giving any output that okay, this strawberry and grapes have been removed. But with the pop function, it returns the value. It tells you that what value has been removed, and the reason why it tells you, because so that you can verify what value it was, because you are just giving a number. Okay, you may be wrong, you may make a mistake, you may give some different number, and it will remove a different value. So that you can verify, so it will tell you exactly the value as well, that what value it was removed. Here you already know in the remove function that what value you're removing. So remove function or the remove method is not telling you anything. Okay, it doesn't has to tell you. But in the pop function, because you are just giving the number, so the Python will tell you that what value it has removed. Okay, so that you can verify that you haven't made any mistake. Okay, so there's some difference between the execution style of some methods. Okay, so Again, like for the string, we can check that what value was in what position. So in the list as well, we can verify that uh, what value is at what position. So let me see at fourth position what value it was. So now it is grapes. So earlier at fourth position it was strawberry, but now because strawberry has been removed, so grapes has taken that fourth position. So you can check the value based on the position by giving that uh, the index. So this is the index position. Okay. So there is a slicing function as well. So let's say you just want to see the first three values. Okay. You don't want to see all the values. You just want to see first three values. So how we do it? In the slicing, we give the beginning position. So because we want to check the first three position, we are giving the beginning position as 0 and the value 3. Okay. Now be cautious because it will return the values at position 0, 1, and 2. It won't return the value at 3. 3 is not included. Okay. So let me run. Aha. So the first three values. So this is at position 0, this is at position 1, this is at position 2. Remember, in the slicing function, the last value in the last index value is not included. Okay. So let me show you again. So what if I change it with 0 to 2? Then it will show values at position 0 and 1. It's not including the index values 2. It's only showing the values 0 and 1. So this is included. This first index position is included, but this is not included. Okay. So you have to be careful about that. Okay. So what if I want to slice the last three values? No, last two. Okay. Um, uh, minus one, minus one, and plus three. Right. Okay. Let's say if I want to check what's the last item. Okay. So in the last item, if I give value minus one, okay, so it will show the value as grapes. Okay. But if I want to check the second last items, I will give value minus two and it will show avocado. So index in Python list is stored in two ways. One is like 0, 1, 2, 3, and 4, like that. And it also stores the index in a negative way, like this is minus 1, this is minus 2, and this is minus 3. Okay. And so again, but if I give a sequence of the values, so like I was giving earlier, minus 3, minus 1. So again, like here we saw that the last index value is not included. Okay, so similarly here, this index value is not included. So it will show the value -3, -2, but not -1. So -3 is orange, -2 is avocado, -1 is grapes, because the last index is not included here. So grapes is not included. So this is how the slicing function works. Okay, this is how you slice the values in a Python list. Okay. And what if I want to sort the items? So let's say if I want to arrange the item alphabetically. Okay. So let's say sort. I just want to sort the item alphabetically. Okay, let's see what the output is. Oh, sorry, the variables is spelled incorrectly. So here, if you see the error, it gives a name error. So I had given the wrong variable name. It was misspelled by me. So when you will do the coding, so you may also experience the same behavior, that the variable may be misspelled by you, and it won't work for you. So you have to check for the name error, and then you have to correct it. So I will correct it, and then I will run this again. And now let me verify the contents of this variable. And if you see, it's alphabetically arranged. They are sorted alphabetically. First is A, and then B, and then G, and then O. But you can also do the reverse. What if you want to sort the items, in a reverse, like first O, then G, then B, then A. So that can also be done. So let's me do that. Sort reverse is equal to true. Okay. So if I specify the parameter like reverse is equal to true in this sort method, and then I run the function, and then you see it has rearranged the values alphabetically, and it has sorted as well, but it is in a reverse way. So A is at the last, then B is the second last, and then G is the third last, and O is like the first item or the fourth last. So this is how you can perform operations on the list, on the Python list. Okay. And we have already, seen the slicing functions, and so let me move on to the dictionary. Okay. So another sequence of items is that you can store the values in a key pair. So let's say I define grocery items. Okay. Let me show you what exactly dictionary means. So in dictionary, we use the curly parentheses. In the list, we use the square brackets, but here we use the curly brackets or curly parentheses. Okay. So in dictionary, we use store the values in a key value pair. Okay. So let's say I want to store the values for the fruits, and then I want to store the values for vegetables, and for the dairy product, and for the beverages. Okay. So I need, because these are strings, I need to specify inside the quotes. Okay. Fruits, vegetables, dairy, beverages, like that. Okay. The problem with the list is that you only see the values, but you are not able to classify, what value belongs to what category. But in the dictionary, you can have a key to, categorize those values. For example, in the fruits, I can, categorize as, so let's say same thing. Okay, so these are fruits. Similarly, for vegetables, I can put, uh, so I can give the value like cabbage. I can give value spinach, and I can give value potato like that. And for the dairy, let's say I'm storing the value milk, and then there is a yogurt, all right. And then beverages, I can store the value as let's say wine and some soda. Okay. So this is how you can categorize these values. For example, these items belongs to fruits, these items belong to vegetables. So this is the beauty of the dictionary, that you can use this key value pair. So fruits is a key, vegetables is a key, dairy and beverages are the key, while the other values are simply values. Okay, so if I just want to search what were the key items, so I can give the keys method, and if I filter, and here you see I am only seeing the categories of the values. What are the key items? If I only want to see the values, okay, and here I see only the values like orange, grapes, banana. I'm not seeing those keys. I'm not seeing those categories. Okay, so then just then what is the benefit of the grocery item? Sorry, what is the benefit of this dictionary? So with dictionary, what you can do, you can just select values only for one select category. Okay, so for example, I just want to see the values for the dairy products. Okay, that's it. I'm not interested in fruits, vegetable. So it's returning me those values only for the dairy products. Similarly, if I want to check only for the fruits and I'm not interested in any other items, and I can filter by giving the fruits key. So it gives me only the fruits list. So this is the benefit of the dictionary, that you can filter or the search values based on the keys. All right. Yes, and one more thing, you cannot have duplicate keys. Keys must be unique. For example, if you have a key defined as fruits, you cannot have another key as a fruits. Okay, so keys must be unique, because otherwise the dictionary, first you won't be able to define the dictionary, and even if it gets defined, you won't be able to search. I don't think you can define with the duplicate keys. So you have to give the unique keys, because keys work like as an index. So like an index cannot be duplicate, it has to be unique. So you have to give the unique key values in the dictionary. And again, so let's say, remember we talked about the pop method in the list, which pops out the value in a dictionary. So let's say I just want to pop out the dairy items. Okay, dot pop, and let me give the key name. So basically, it is also returning me these values. So pop method is telling me that not only this key dairy has been removed, but also the values. So if run this dictionary again, so I don't see the dairy items. I only see fruits, vegetable, and beverages. Okay. So we are done with the dictionary. So we have done discussed very simple Python data types. If anyone has any questions, they can ask me. Okay, so silence. So I assume that folks don't have any question. So let me move forward. So now, so this is very interesting. The Python library, okay, which is called the NumPy. Okay, so basically, some developers they have already written the source code of NumPy for you, so that you can perform some computations, which won't be feasible with the with the normal Python data types. Okay, like with Python list or Python dictionary. So with NumPy, you can do much faster calculations, and you can even perform those transformations which are not possible in the Python data types. Okay, so NumPy stands for it's a short abbreviation for the numerical Python. Basically, you can perform numerical operations. That's why it is called NumPy or the numerical Python. Okay, so it stores the structure as an array. Okay, and why array? What is the difference between the list and the array? So there are some similarities. Like a list is also sequence of the values. So array is also like a sequence of values. Like in a Python list, you can slice the items, slice the values based on the index position. So same thing you can do with the array as well. However, with the difference is that you can perform some convenient functions, like you can find the mean, you can do the standard, you can find the standard deviation, which may not be possible with the list. You can do with the list as well, but you have to write your own custom code. But the numerical Python will save you time, it will save you effort. So let's define the NumPy array. So let me define the first variable. First array is equal to, uh, so let me first import this library. Import NumPy. Okay, you can run the import NumPy as such, or you can also give it a short name like NumPy as NP. Okay, so when you run this statement, you can use it as a NP. You can just use a short abbreviation. So let me define the first array. Okay. Um, so NumPy dot array, and so this is how you define the array. Inside you can give the list 1 to 100, 50, 25, 500, and then 625. I'm just giving some random numbers. Okay. And if I type, if I just want to see what's the type of this, it says it's a array numpy dot nd array. So basically it's an array shape. Okay, so what it means is that if I, so this is how it gives the output array of these these numbers. So you may be wondering, then what's the benefit of keep making it array? Well, you will see it later, because these arrays can be multi-dimensional array, like two-dimensional. So and you can, and once you make it two-dimensional, then you can perform just a row-wise operation or the column-wise operations. Okay, so let me define a two-dimensional array. First array, I will say array underscore 2D. This means as a two-dimensional array. Can make it as a numpy dot array, and inside the list, yes, so 10, 20, 30, 40, 50, 60, then 70, 80, then 90. All right. So I'm getting small error. Only two non-keyword arguments expected. Oh, sorry. Let me give. Let me show you what exactly. Oh yeah. So now I see what the problem is. So so you can get some errors like that. Okay. So let me go back to the original error we were getting. So you may be wondering what went wrong, and you have to do a little bit of analysis. So I'm giving this sequence of values, a list, but I have to give it as a list of list if I have to make it two-dimensional. Okay. Earlier I was just giving a sequence, but it was not packaged inside another container or kind of a list. So it was giving me the error. So now it works. Okay. So now let me print the output. Aha. So here you see the two-dimensional array. Okay. So if you see, it has three rows and three columns. So the beauty of the arrays is that you can do computations much faster than the Python list data types. Okay. And also, if you just want to do some operations only the row wise or column wise, you can easily do it. Okay. So let me create another array this second, or I will say second like that, equal to what let me perform some operations. Let me perform some um, the multiplication on this array. Okay. So let's say I want to triple the values of this matrix. Okay. So for example, yeah. So for example, so just if I want to triple the value, I just have to multiply it by 3, and I have to give the this array name. Okay. Now let me verify the content. So if you see, it is a much better to perform computations. I didn't have to multiply each value one by one. I didn't have to multiply each value one by one. In the NumPy array, you can multiply the whole matrix or the whole array with a number, and then the result will be the multiplied value. So if you see the 30th, this is a triple value of 10, and then 60 is the triple value of 20. Similarly, 180 is the triple value of 60, like that. So I didn't have to multiply every value one by one. If you are using Python list, you had to multiply every value one by one. First, you have to slice, or sorry, first you have to search that value by index, and then you have to multiply. But here, you don't have to do that. You can multiply the whole array at once. So this is the result. This is showing the triple value. So now you can also perform you can add one matrix with another matrix. You can subtract one matrix or one array with another array. So let's say what happens. I just want to get the double value of this array underscore 2D. So what I can do, I can subtract the value from array triple to array 2D. Okay, that's it. And if I want to check the value of array double, here you see. So now it has subtracted. So the value based on the each index. So you subtracted 30, you subtracted 10 from 30, you subtracted 20 from 60, you subtracted 30 from 90, and so on. You subtracted every value one by one. And the beauty of the NumPy array is that you perform that calculation so easily. You didn't have to search every value one by one. You didn't have to subtract the value one by one. This NumPy library, this NP, this NumPy library is taking care of it. So it is making your life very easy. You know, if we're using Python list instead of this NumPy array, you had to write a some program or some code to search these values one by one, and then you have to subtract value one by one. But in case of NumPy, you don't have to do that. Okay, so this is the beauty of the NumPy arrays. Okay, and then you can also perform the scientific computations, like if you just want to check the mean. So for example, here, this is the array. Okay, um, well, let's see. Let me take this mean of this array. If I give the mean, uh-huh. So the mean of all values is 100. Okay, and if I want to check the standard deviation of this matrix of this array, so for this we have this method, standard deviation std, and this shows the value 51. Okay, if you are using Python list instead of this NumPy array, you would have to again write a very lengthy source code to calculate the mean and to calculate the standard deviation. But with NumPy array, you are already gifted with these pre-written methods, so that you don't have to reinvent the wheel. Okay, you can just execute the methods and you can save your time, you can save your effort. Okay, um, but there's a problem with the NumPy array. The problem with the NumPy array is that uh, you don't know the header of the columns. You don't know what column represents what. Okay, and also in the NumPy array you can save items of only one data type. Okay, so let's say there's a list, um, and I'm saving these three values. Sorry, one, then sorry, true. Okay, this sorry, list uh, template, right? So this is a temporary list I have created. So if you can see, it has uh, three different types. So first is a string data type, the second is the integer data type, and the third is it is a boolean. Booleans means basically it is either true or false. Okay, so if I type the type of you know let's say I try to check the type of each value. So this is the first value at the 0 index. Okay, and similarly this is at the first index and this is the second index. Okay, and let me run. Oh, this some error. This is the error. So if you see, when you ever get this EOF error, so that means there's some problem with the brackets or parentheses. So type is a, kind of a method. So you have to close its, the parentheses. I had forgotten to close the parentheses. Similarly, here as well, you have to close it. And here it is, I think, already closed. So let me run this. Okay, so now it it has run, and if you see, so it shows the three different data types. So first is the string, which is the mango. Mango is a string at a zero index. Then the second, at the first index, the value is one. So one is integer. Okay. And then at the second index, the value is true. So true is a boolean. So it is showing the value boolean. Okay. But the problem with the NumPy array is that it stores all values with the same class, with the same data type. So let me define um, the NumPy array is equal to is this. Okay. All right. So now I have created a NumPy array out of this list. So now I will check the data types of this NumPy array. Instead of list, I will type array. Okay. Okay. So now if you see the same values, mango 1 and true, when they were in the list, Python list, they were showing their correct original data type or their class, that string, integer, and boolean. But in the NumPy array, the same values, mango 1 and true, they are converted into strings. And the NumPy converted it into strings because NumPy is a little bit, uh, is not flexible. NumPy is arrays, they are not that flexible, so they store the values in the same class. And I think the reason is that maybe because so that we can perform computations, on them easier, because if there are different classes we can perform the computations. For example, I cannot, if I want to take the mean or the standard deviation, but the items, or if the all items are in the numeric, I can calculate the mean, I can calculate the standard deviation. But if some items are numeric, some items are alphabetic, then I cannot calculate the mean, I cannot calculate the standard deviation, because not all the items are numeric. So that is the reason uh, the NumPy array, they prefer that all items, they should belong to one class or one data type. Okay. So this is how we can we have performed some operations. So I can also do Emma, I have a question. I know it has been almost a 1 hour. Is how much time do you think the folks have? Can we extend it for another hour?
Yeah, sure. So there isn't a workshop directly after this, so it can be however long you want it to be.
Okay, sure. So the beauty of the NumPy array is that, for example, if there's a matrix, so this is array, you can reshape it. Okay. So for example, this array underscore double. Okay. So currently its shape is, let me calculate its shape. Uh, what shape? It is telling 3 rows and 3 columns. Okay. So basically 3 rows and 3 columns. I can reshape it as I want. So for example, I can reshape by specifying that I want 5 rows. Okay. So basically these are 3 into 3 9 uh, values. So let me give um, 9, 1 row and 9 columns. So here, if you see, all the items are in the in the different columns. So there's a 1 row, but there's 9 separate columns. Or I can reshape it as 9 row and 1 column. So all the items are, rearranged in a different way. So there are different. So there are 9 rows, but only in 1 column. So this is the basically the beauty of the NumPy arrays, that you can perform metric operations and you can reshape them as you want. Okay. Um, so then there are, we have gone through the add operations, multiply operations, but there are some logical operations as well, like and or greater than or equal to. Okay. So let's say I want to filter only those values which are greater than 70, or greater than, yeah, greater than 70. So array greater than 70. Okay. So here, if you see, the first is false, second is false, third is false. Basically, it is telling you that here in array underscore double, 20 is 20 is not greater than 70, 40 and 60, they are not greater than 70. But after 80, all the values are greater than 70, so they are true. Okay. So I can use these Boolean values as an index. Okay. So what that means is, so array underscore double, and I can give this criteria as an index. So what it will does, it will return only those values with the true Boolean clause. Okay. Um, so it is returning only the values which are greater than, um, okay, 1 minute. Yeah, which is greater than 70. So it has included all those values. It has excluded the values like 20, 40, and 60. It is showing values only those which are greater than 70. I can even perform the AND operations and add one more criteria. But if I want to add one more criteria, that they're greater than 70, but they are less than 150. Okay. So I will give the AND operator, and I will give the value 150. Okay. So now I am checking for two conditions. Okay. That if this is greater than 70 and as well as less than 150. So now if you see, oh, sorry, I gave the wrong operator. Yeah, it should be less than 150. So here, if you see, these all values which are returned, they are greater than 70 and less than 150. So you can perform these kind of operations uh, in within NumPy arrays. Okay. So now move on to the pandas. So pandas is even better than NumPy array. So far we have seen that how NumPy array is better than Python list, and but we can also check. But now we will see that the pandas library is even better than the NumPy's array, and the reason is that because you can structure the the, the matrix values, or the structure the array in a nice format, in the tabular format. So let's check the content. So these were the original contents, okay, of the NumPy array. So let me import the pandas library, and because I want to make my life easy, and I will just give a short abbreviation as PD. You don't have to give, but most of the programmers, or I will say 99% of the programmers, they use these short abbreviations so that they have to type less. Okay. So now the pandas library has been imported, and now what I will do, I will create a data frame, pandas data frame. Um, so the first data frame, okay, and I will say pd dot data frame,
Also, we
and
have a question from the audience.
yep, sure.
Okay, so someone is wondering, are there other platforms we can use instead of Jupyter?
Oh yeah, there are other IDEs available. For example, Spider is very popular. Let me show you what's the Spider Python. So you can use this Spider. It's an kind of, it is called IDE, which basically is a short abbreviation for the Integrated Development Environment. So you can code, your program in the Spider. Some programmers prefer Jupyter notebooks. Some programmers prefer Spider. So it depends on you how to, uh, like what platform you prefer, what tool do you like. Based on your comfort level, you have to decide. Okay. So for example, in Jupyter Notebook, I prefer because I'm executing every statement, every Python code one by one. Okay. So I'm checking the values right away after executing every statement. So this is the output. This is the output of this statement. This is the output of this statement. So for me, Jupyter is better, but for other programmer or other developer, the Spider will be better. So you can use whatever you like based on your comfort level.
Okay, cool, thank you.
You're welcome. All right. So let me frame it, frame this this tabular. Let me frame this array into a tabular structure with a nice header. So what I will do, I will first pass this array, and also want to give the name to these columns. So what I will do, I will create a list of the columns. We'll say first column, then second and third column. Okay. So what we call array in NumPy, we call it a data frame in Pandas. The reason we call it data frame because you will soon see uh, the tabular structure. So if you see how nicely it has been arranged, because it shows the values in a tabular structure. Okay. And you also see the column names, because here I have given the column names: first column, second column, third column. So you can easily filter or the values based on the column names, because this is kind of a label. Okay. So that's why pandas data frame is even better than NumPy. However, NumPy is far faster than the pandas data frame, because pandas data frame is built on the top of NumPy array. Okay. So that's why NumPy array is faster, because data frame is still using NumPy in the back end. So, but for the developer, it gives a better readability or usability, and it structures your data in a very good way. Also, you can store the values of different data types in the same column. You can't do that in the NumPy, but in the in the in the pandas you can do that. So let's see if we can filter by the column names, the values by column names. Okay, so let's see if I give the column name, uh, give the column name as, huh, okay, it gave me error. Okay, the reason is that it gave me an error because basically it's a key error. Okay, the Python errors, they are not uh, very detailed. They are not in, like, they don't have any detailed description. They will have very vague information. So basically it just tells key error. So it doesn't tell why it is key error. So you have to analyze yourself that why it is a bad key. So the reason is that because you have to give both the rows and the columns as a key. You can't give just as a column. Okay, if you're using the lock method. So let's say if I give the colon and then comma. So this first in value is for the rows. Okay, like what rows you want. Now if I want all the rows, you can give this colon. Okay, if you want the only second row, you can give this second. But if I want the all rows, I will give the colon. Okay, and then in the columns you have to give the column name. So now let me run this. If you see, it is showing values only for the second column, 40th, 100 and 160. Okay, so what if I search only for the second index position, or the row value of the second index. So second index is this one, 160, and the column is this one. So we should get the value of 160. So if you see, the value is 160. All right. So basically in the lock method, lock is basically, it is telling you what is the location. Okay. So lock is short abbreviation for the location method. Okay. So with this lock, you can uh, locate the values. What if here I have a label is given as 2. So the column is also at the third column is also at the second index. What if I give the second index here as well? The column as well, if I give the second index. So this is the second index. Let's see if it works. So it gives an error again, some type error. Okay, now it is telling me it's a type error. Okay, so the reason it is that because it's expecting the column label as a string, but we are giving as the index. Okay, so how can we use it as an index? So for that, there's another method called iLock. So I is for the index. Okay, so if I give I with the lock, which is the iLock, and then if I run this, and now it is giving me the value 180, which is the second row and the third column. Third column is at the second index. First column 0, second column the index 1, and the third column is at the the second index. Okay, second column is the first index, third column is second index. Okay, give me a minute. My battery is running out. Emma, hello, Emma, can you hear me?
Yeah, what's up?
Okay, give me a break of 2 minutes. I need to get my charger cable for my laptop.
Okay, yeah, sure.
So I'm stopping my camera. Okay.
Okay, sounds good.
Hello.
Hello.
Okay, sorry. I was getting dry, so I had to get some water as well.
Okay.
All right. So let me get back to uh, where I was. Yeah. So we were talking about the pandas data frame, and we were talking about how we can filter a value for a certain row and a certain column. So if you use the lock method, you have to give the label of the column as such. But if you use the iLock, which stands for the index locator, so you can give the index value for both the row and the column. So for example here, the second row and the second index, column index, it gives a value of 180, right? So this is how the pandas data frame, you can easily search if you want to search any values. Okay. Um, Now I will, because the time is running out, I will quickly jump on to the case study. Okay, sorry. First, I will describe what is machine learning. Okay. So machine learning, basically, it is a field of the study that gives computers the ability to learn without being programmed. Okay. So that once a machine learning algorithm is trained, uh, you don't have to it can make the prediction on its own. You don't have to tell how to predict. Okay. It can make prediction on its own once you train it with some kind of the data. Okay. The second definition of the machine learning is that it's a kind of a computer program which learns from the experience E with respect to some task T and some performance measure P. Okay. uh, and basically it checks if its performance on the task T as measured by the P improves with experience E. Okay, basically the goal of the machine learning is that it will keep on improving itself with the experience as soon as it's getting trained more and more. So let me ask you a question. Suppose your email program watches which emails you do or you do not mark as spam. Okay, let's say you have a program which is monitoring like what kind of emails you're marking it as a spam and what kind of emails you are not marking it as spam. And based on that, it learns how to better, filter the spam. So that algorithm will learn from you how to, the filter the emails and how to categorize that email as spam or not spam. So the question will be, if you read this definition, that programs learn from experience E, the task is T, and the performance measure is P, then what is the task T in this setting? This is my question to you. Okay, no answer. It's very simple. So the task T is basically it is the classifying the emails. Okay, it is a classifying emails because classifying emails as spam or not, that is a task. And the performance is how better or how correctly you classified them as spam or not spam. So that's the performance. So what machine learning algorithms do, they based on the performance and they based on this experience or the event that emails are spam or not, they learn and they improve themselves. Okay, so let's say if their performance measure is only 50%, so they will try to improve and they will try to learn and they will try to have accuracy of more than 50% by learning from this experience, by learning which emails are marked as spam and which are not, right? So how do machines learn basically? So we know that machine learning algorithms learn, but how do they learn? Well, the answer is from the data. We give them some information, we give them some data. So in today's world, we are creating huge volumes of data, whether it's from text message or email or social media post, or the some photographs or videos. And some data is getting collected by millions of sensors in our home, in our car, in factories. So all of that data is fed as an input to the machine learning algorithms. Okay. And so using that data, a machine learning algorithms can train themselves, and then they can make predictions. Okay. How they make predictions? They find the relationship they find in the data, relationships, or I should say the pattern. What kind of pattern is there in the data? Okay. So you will learn it in the next slides, how the relationships are, or how the patterns are found. So for example, this is just an high level example. Okay, it's a very complex algorithm, so I won't write the program for this. So what machine learning algorithms are do, they are classifying the pictures and giving them the labels. So for example, if this is a car, by looking at the picture, algorithm will say yes, this is a car, and it will assign it a label. By looking at the picture, algorithm will say yes, it's a bus. By looking at the picture, algorithm will say yes, they are cyclists. Okay. So we are giving them some, first we train them, we give them some pictures. We tell them that these are their labels. So labels means this is the bus, this is the car, this is cyclist. And then onwards, going forward, based on the new pictures, then machine learning algorithms, they can classify the pictures. They can assign them the labels automatically. You don't have to assign the labels. Machine learning algorithms will do that. Okay. So this is just an example how machine learning algorithms, make prediction or they do the judgment. So machine learning algorithms, there are three types of algorithms. One is a supervised learning, other is the unsupervised learning, and then there's a reinforcement learning. There's something other semi-supervised learning as well, but this is not very much used. Supervised learning and unsupervised and reinforcement learnings are mainly used. And out of these three, supervised is even more popular. Okay. So let's talk about what is supervised learning. So in supervised learning, basically, we already have the labels. Okay. So we tell the machine learning algorithms, okay, so these are the labels. So we train the machine learning with the labels. So for example, if you look at this example, this picture, so these are the labels: bus, car, cyclist. So we are telling the machine learning algorithm that these are the labels. And going forward, for the unseen data, for the unknown data, okay, algorithm has to find the labels on its own. We won't tell the labels. We won't assign the labels. For the seen data, that data we have and the labels we have, we will pass it as input to the machine learning algorithms, and then algorithm can learn by using that data. So this is an example of supervised learning where we have the labels. Okay. And then supervised learning, again, we classify into two different types. One is a regression learning, or there is a classification learning. So regression learning, if you see, these are like some continuous values. So these are mainly numerical values. Okay. And in classification, there will be like discrete categories. Discrete categories like yes or no, spam or not spam, true or false, like these kind of discrete categories. So that's called a classification model. While in regression, it will be numerical value like 70 degrees Celsius, 80 degrees Celsius, 85 degrees Celsius. Okay. So let me jump to the next slide, and that will help you understand it better. So in the regression, basically I'm looking for the numerical value. Okay. So for example, I just want to predict what is the temperature tomorrow. And the machine learning algorithm will predict it as 84 degrees Celsius. Okay, so that's an example of regression. Regression means continuous numerical values. If you see this scale, continuous numerical values. So based on the data, it will predict the values. That's called regression. Classification is something like discrete. Okay, whether it's hot or it's or either it's hot or it's cold. Okay, so it has categorized these set of temperatures into cold category and these set of temperatures grouped them into hot category. So both the regression and classification, they have the labels, but the difference is that in regression you have the continuous numerical values uh, as an output, but in the classification there will be discrete values. It will be like yes or no, hot or cold, like that classification. Um, so then there will be so another example of classification supervised learning is that this spam email. Okay, so let's say you get an email, okay, and you think that it's a spam, okay. So what you will do, you will click on the spam button, okay, and when you click on the spam button, this email will go to the spam folder. But what is happening on the back end, that the computers or the servers, okay, or the machine Google's machine learning algorithm, they are learning what type of emails you are marking it as a spam. So if you clicked on spam, then Google will algorithm will learn, okay, so this email has this subject and this type of content. So that means this is a spam. For example, sometimes you get a spam emails that you have won the lottery, like you have won the $100,000. So because those kind of emails, they are spam messages. So these days Google machine learning algorithms, they are very trained, so they already send those emails to their spam folder. Okay, so this is a perfect example of the supervised machine learning, because there are labels like spam or not spam. And when you click on spam, you are teaching machine learning algorithm, which is at the Google server, to learn that this type of emails are spam. And then algorithm will say, okay, next time I will take care of it. You don't have to mark it as spam. I will automatically move this email to the spam folder. All right. And then the next is the unsupervised learning. The difference between supervised and unsupervised learning, it's that uh, in the unsupervised you don't have any labels. Okay, for example, in the supervised, you have the labels like either spam or it's not spam. But in unsupervised learning, you only have the data, but you don't have the label. Okay. So then in such case, what it does, machine learning algorithms, they make the clusters of the similar data items. But we still don't have the labels. It is just we are making the clusters. So the algorithm will try to find a common pattern between the different data items, and then it will group together those data items. So this is first cluster, this is second cluster. So both clusters, like, they are little far from each other because they don't have kind of that common pattern. So this is first cluster and this is second. So let me show you how it works. So let's say you are looking at the Google News, okay? And the Google News, if you see a news item, let's say there was a oil spill from the British Petroleum, okay? And what it will do, it will club together some other related stories, and it will make the cluster. So if you see, it's a kind of a cluster, and there are some other uh, stories related to it. Okay, And this news is different. It because it is about the US stocks, it is about the recession. Okay, this news is different from the oil spill, so it has a separate cluster. And in this US stocks cluster, you can see the another news. It says the longest recession since 1930s ended in. So this is how the Google News is making the cluster of the similar news. Okay, so let's look at this slide. So what it did, it clubbed together the news of the oil spill from three different sources. One is from the CNN website, one is from the Guardian, one is from the source, and it made a one single cluster. Okay, so all three related news, they are into the kind of the same section. So this is how unsupervised learning, because we don't have the labels. Okay, we don't know what type of news will come tomorrow. We don't know what type of news will have what label, whether it's of some stocks related news, or it will be of oil spill. And even if we try to assign the labels, there will be hundred thousands of labels for each news. Okay, so it's better to make the cluster of such news and group them together. Okay, so this is example of unsupervised learning. So next, move to the reinforcement. This is the third type of the learning. So basically how it works, so there will be an agent. Okay, agent base, you can in the let's say there's a robot. Okay, we want a robot to learn something, so we will call it as an agent, because agent has to learn, and it will take some action. Action is like, uh, for example, it is moving forward. Okay, it has to move forward. So based on the actual action, we will either reward it or we will punish it. So let's say instead of so let's say if it is moving forward, so let's go to this slide. So if you see these tiny robots, okay, so basically how they are trained is that if they score a goal, we will reward them. Okay, and if they don't score a goal, or if they score their own goal, you know, or if they pass the ball to the opponent team, so we will punish them. And if they pass ball, if the this robot is scoring the goal at the opponent's side, or if the this robot is passing the ball to its a fellow the team player, then we will reward it. Okay, so we can reward it by increasing some score, and we can punish it by decreasing its score. So this is how the robots learn, and this is called the reinforcement learning. Reinforcement, because we are rewarding it, we are we are we are punishing it based on the actions they take. Okay, so here these all robots are agents. Okay, and they are taking actions by playing the football game or the soccer game, and if they score the goal, we reward them. If they don't score, or if they are unable to secure the ball, then we punish them. All right, so here's a question. Okay, now the question is that, um, which examples are unsupervised learning? So first is your labeling email as spam or not spam. The second is that you are grouping a set of articles about the same story. The third is that you are grouping the customers into different market segments. And then the fourth is you have to classify the patients, whether they are diagnosed with the diabetes or not. So out of these four options, which options you think that they are unsupervised learning? So this is my question. So again, I'm giving you a hint. Hint is that in the unsupervised learning, you don't have any labels. Okay, no answer. It's okay if the answer is incorrect. That's okay. I can help. I can explain. But I just expect some answer. What?
I think you could try asking the question again.
Oh, okay. So my question is, of the following examples, which would you address using unsupervised learning algorithm? So there are four examples. First is the email labeled as spam or not spam. Second is you're grouping the set of articles about the same story. Third is you're grouping the customers into different market segments. And the fourth, you're uh, classifying the patients diagnosed as either having diabetes or not having diabetes. So out of these four, uh, which examples are unsupervised learning algorithm?
Okay, and yep, there it goes. The chat just appeared. Someone says number three.
Number three. Okay. Anyone else? Okay. Okay. And why do you think it's number three? So I just heard that it's an option three. So why do you think? I'm just curious to know.
Oh, and the chat and the live stream are a little delayed, so it might take some time for the comments to come in.
Okay.
And you can see on your screen that someone says there are no pre-existing labels.
That's very good. So you are actually partially correct. Uh, so the correct options are option two and option three. Even in the option two, we don't have the labels. We are grouping the news articles, related news articles together, but we don't have the labels. We don't have the labels like it's a politics, is a sports news, or it's a finance related news. No, we don't have the labels. So second option is also correct. So both second and third options are correct because in both of these we don't have the labels. So in both of these cases, we are grouping them. We are grouping the items, or I should say we are making the clusters. So in the second, we are making the cluster of the news articles, related news articles, and the third option we are making the cluster of the customers with having similar market segments. Okay. In the option 1 and 4, we are having a label because the first option it clearly says that they are labeled as spam or not, and the fourth option as well we are having the labels that diabetes or not diabetes. All right. Does anyone still has any questions?
Not that I can see in chat.
Okay, good. So now let me move to the case study. Uh, so this case study may take additional 30 minutes or more than 30 minutes. Emma, how much time do you think you can have additional time?
You can have like as much additional time as you want. Just like maybe try to keep it like
Okay,
as
that's good.
relaxing. Yeah.
So yeah, so let me move on to the case study. Okay, so in this case study, uh, we want to predict the house price. Okay, so for example, if you have the data of one city or one county, and you want to predict the price of a house. Okay, so let's say you are told that the house size is, some square meter, then what will the price of that house? Or if you are told that this house has two bedrooms or one bathroom, or four bedrooms and three bathrooms, then what will be the price? Or this house has a basement, or it doesn't have the basement, then what will be the price? Okay, so we will be predicting the price based on all these, the features, the size of the house, the number of bedrooms, the number of bathrooms, they have the basement or not. Okay, so this will be example of the supervised learning and regression. So supervised learning is that, because we will have the in this data we will have the labels. So we will train the machine learning algorithm or the machine learning model with the price label. So let's say we will give the data of 1,000 houses, and all those 1,000 houses will have the details like the size of the house, the number of bedroom, the number of bathroom, if the basement have is there a basement or not. And then we will also pass the label. The label is a price, that what's the price of that house. Okay, so then the machine learning algorithm will learn to calculate the price based on those features. Features means the size of the house, bed number of bedroom and bathrooms, and so on. And then we will pass some data for which we don't know the price, for which we don't have the price information. And then we will ask machine learning algorithm to predict the price. We will tell machine learning algorithm, hey, you have been trained, you know how to calculate the price. So now please help us in calculating the price of this unseen and unknown data for which we don't have the labels. We only have the features available, like we only have this information like house size, the number of bedroom and bathroom, and so on. All right. And also, it's a regression example, it's not classification, because regression means it's a continuous numerical value we have to predict. It will be $100,000, $300,000, $500,000. Okay, if we had to classify the house as expensive or not expensive, cheap or not cheap, then it will be classification. But here the output value is not the discrete output value. Here the output value is a continuous numerical value, so it's a regression example. Okay, so let me move on to the case study. Okay, so this is a case study. Okay, and I'm using my Jupyter notebook. So we have to predict the house sales in a King County in the USA. I think the King County is in the Seattle or near Seattle. Um, and I have these features for for this data, like the date the house was sold, the price information. So this is the label, and we also call it as a target variable. And then we also have the number of bedrooms and the number of bathrooms, and like uh, the total floors in the house, whether the house has one floor or two floors, the house has a waterfront or not. All these features, we will use to train the machine learning model, that based on these features, this was the price for the known data. So what will be the price for the unknown data? All right, for which we don't have the price information available. So for that, we import these libraries. So we have discussed the pandas libraries, we have discussed the numpy library, and there is another library as well, which is called the sklearn, which is very important. So this sklearn libraries have some models written. So using these libraries, we import those models, machine learning models. The pandas and numpy library, they will help us to import the data. So once the data is imported using pandas and numpy, we will use this sklearn. Sklearn is a short abbreviation for the scikit-learn. to create and write our machine learning model. Okay, these algorithms like matplotlib and the seaborn, they are used for creating the chart. They are used for creating the graphs so that we can visualize the data. Okay, so let's see how it goes. So first we import the data. So this is the first function we do. uh, when we import the data, so you can import the data from your local computer or wherever the file is stored, but I am importing the data from some internet cloud storage. So because it is a CSV file, it is ending with .csv, so I will use the pandas read underscore CSV method, and there I will give the file name. Okay, so once I execute, and then what I will do, I will execute this method df.head. So this is how the data looks like in, so this is the price information. So, and this is what we want to predict. But because this is the known data, this is the training data. For training data, we will have the labels, we will have the values available. But for the test data, for the unknown data, we won't have the price information available. So right now you are seeing, what you are seeing is the training data. So for that we have the label price available. Okay, and the head function, it shows the top 5 rows. Okay, by default it shows 5 rows, but you can change it to 10 to see the first 10 rows. Here if you see, you are able to see the 10 rows. So so for this house, there's a one bedroom and three bathroom, and this house, it has a 4.5 bathroom, and this 4 bedroom, so like that. Okay, and so waterfront, like 0, and it will have value 0 1. So 0, I think it basically they don't have the waterfront, and value 1 will mean they have the waterfront. Okay, but we can check that later what the value 0 and 1 mean. Okay, then I will try to check the data types of all these columns. So to check the data types, I will run this function. This is a data frame dot d types. So you see, most of the values are integer and some are in float. So that is good because we want to perform numerical computation. So we want the values either in float or in the object or in the integer. There is a one field which is the date, and this is something in a different format. It looks like it is in the string format. So any string format, it will show as an object. So if I scroll up, you see the date is showing, it's not it's not readable. Okay, because it's in a string format, so we will convert it into a proper format. Okay, we can then also run the describe method. So for example, we want to see what's the mean value. Okay, so for example, for the price, the mean value is 5.4 into 10 raised to power 5. So this is scientific notation. It shows e plus 0.5. So e plus 0.5 means 10 raised to power 5. So basically you will be multiplying 5.4 into 10 raised to power 5. So that's the mean price of the house. Okay, and the standard deviation. So this is the standard deviation. Okay, 3.67 into 10 is power 5. Okay, so first, so 25% of the houses, the lower 25% of the house have the price up to 3.2 into 10 is to power 5. Okay, and then and the top 50% will have 4.5 into 10 to power 5. So 10 to power 5 is, I think, 100,000. So 100,000, it basically it made it, I think it means 450,000, that's a price. And the top 75% will be uh $645,000, 645,000. Okay, and this is a maximum price. So I think it tells us $7 million. It's a 10 to the power 6, so I think it's 7 million. All right, 7.7 million. All right. So the whenever you import the data, so there will always be some information which is not helpful and which you don't want. Okay. So for example, there's a column like ID. I don't need the ID. ID is just a sequence number 1, 2, 3, 4. So machine learning, it won't be helpful or beneficial to machine learning. So I will remove the ID. And this unnamed column, we don't know what the unnamed column means. We don't have the information. So we can delete that. Basically, our goal is to pass the clean data to the machine learning algorithms. So what I will do, I will run this drop method and I will pass that column names, ID, and this unnamed. Because I have to tell that these are the columns, not the rows. Because if you don't tell that, then the drop method won't know whether he has to drop the rows or he has to drop the columns. So you specify x is equal to 1. X is equal to 1 means it's a column wise axis. If you specify axis value as 0, it would mean that you are specifying the row wise data. But because we want to remove or drop the columns, so we are specifying axis as 1. Okay. So after executing this, we see that the ID and the unknown columns are removed. We don't see the ID and unknown columns, right? And similarly, now we had earlier seen that this date object is not readable. All right, I don't see the dates. I can't read the dates. So what I will do, I will convert it into a good format. So I will run this method pd dot to underscore date time, and then I will give the column name, to which column I want to convert into date and time format. And if I run this function, and you can see the date is formatted correctly. 2014 is a year, 10 is a month, 13 is the date. So it means 13th of October 2014. Similarly, all the values in these columns are showing it as year, month, and date format. So now we can read the dates. So this operation, basically what we are doing is called the data wrangling. Data wrangling is because whenever you import the data will be in the either in the incorrect format, or it will have invalid or incorrect values. So you have to play with the data to make it to correct it. Now, this data frame may have some missing values. Okay, and so when you have some missing values, you have two options. Either you delete or remove the rows or the columns where it has a missing values, or you can replace the values with some other value. So if you want to replace, you can replace it with a mean value. Let's say uh, um, the price column doesn't have the all values. So let's say some values are not available. So you can take the mean or the average of all the values which are available, and then you can impute that or insert that average value into those places where the value is not available, the price value. Okay. So let me take a 2 minutes break. Again, I need to get some water. I will be right back. Emma,
Yeah. Okay.
I'm just taking a 2 minute break, short break, just to get some water. Okay.
Yeah. Okay. Sounds good.
Yeah. Hey, Emma.
Yeah, hello.
Okay, yeah. So I have just one question. Is like tomorrow also the session this will be running, this training session, or I was just wondering if I can postpone something to tomorrow, or you want me to cover everything today?
Yeah, I think it's possible we can schedule like an additional like workshop for you tomorrow.
Yeah, that will help me because it has been more than 2 hours of session, and I think it will definitely take more than 30 minutes, so or it may take even 1 hour. So we can plan to meet tomorrow at the same time, and we can yeah.
Tomorrow at the same time, the hackathon will be over. So our hackathon ends at noon.
Okay, so right, I can quickly go over it. I can finish it, and so because if tomorrow we don't have time, then today I will quickly finish my case study. But
Yeah.
it will be little fast and will be little quick. Is
What we
that
can
okay
also
with
do
you?
is that we can do it after the hackathon, and then people can just like view it afterwards. It doesn't like necessarily have to be like in the event timeline.
Okay, so what time do you prefer tomorrow?
We can discuss this like afterwards. So should I end the broadcast now?
Okay, sure, sure.
Okay, cool. So I guess thank you everyone for coming, and if you're interested, maybe like turn on your notifications, and then we'll make any announcements for if there's going to be like a follow-up session, like in what